Okay, today we start continuation of yesterday's Unit 5. Today's session we cover security monitoring, security architecture design, data security and application security. Now see the security. What is meant by security monitoring? It is a critical component of cloud security and management. It relies on automated solution, cloud security monitoring, supervise virtual and physical servers to continuously access and measure data, and even application or infrastructure behavior for potential security threats. This assures that a cloud infrastructure and the platform function optimally while minimizing the risk of costly data breaches. Now you see there is in this diagram there is a customer and there will be end user. They called as a security expert team. If there is any data will be shared or there any security lag happens in between the network, it will continually monitor and written in the cloud log, so we can analyze and later. Now what are the benefits of cloud security monitoring? It provides easier way to identify pattern and pinpoint potential security vulnerability in cloud infrastructure. And also when the customer data is stored in the cloud monitoring can prevent a loss of business and fluctuation for customers by ensuring that their personal data is safe. First of all, the uses of web service can increase security risk, yet cloud computing offers many benefits for business, from accessibility to better customer experience. Cloud monitoring is one initiative that enables companies to find the balance between the ability to migrate risk and also taking advantages of the benefit of the cloud, and it should so without hindering business process. So now see how cloud security monitoring. These are all the several approaches to cloud security monitoring. Cloud monitoring can be done in the cloud platform itself on premises using on enterprises existing security management tool or via a third party service provider. Some of the key capabilities of cloud security monitoring software includes scalability, visibility, timeliness, integration, auditing and reporting. Now we see scalability. What is meant by scalability? It is also a tool must to be able to monitor large volume of data across many distributed locations. What is meant by visibility? The more visibility into application user and file behavior that a cloud monitoring solution provides, the better it can identify potential attacks or compromise. Timeliness. The best cloud security monitoring solution will provide constant monitoring, ensuring the new or modified files are scanned in the real time. Integration. It is also a monitoring tool, must integrate with a large wide of cloud storage, provide to ensure full monitoring of organization cloud usage. Auditing and reporting. Finally, it provide auditing and reporting capability to manage compliance requirement for cloud security. These are all the various software monitoring tool for a cloud. Now next topic, security architecture design. As the first step, architect need to understand that the security capability are offered by the cloud platform PaaS IaaS. It's an architecture for building security into the cloud services. There is a security strategy and even data center and a developer centric fully managed model, and other side identity access management services. Inside that, the automated lifecycle management followed by the platform as services and the infrastructure as services. Finally, security service infrastructure and right behind security service application. There is a many security or service application. Even the security service infrastructure as a firewall API, SSL, and even the security service application as a user. Now, see, these are the following best practices of migrate a risk of to cloud services. First, we say architect for security as a services. Application development in the cloud involve multiple services including automation of DNS, domain name service, load balancer, network, and quality of services. Even the cloud deployment process that depends on the security process such as firewall, policy creation, certificate provision, key distribution, and approaching pen testing. It also improves operational efficiency. The next one is implement sound identity, access management architecture and practices. Scalable cloud bursting and elastic architecture rely less on network-based access control or warranted strong user access management architecture. Cloud access architecture should address all aspects of user and access management lifecycles for both end user and privileged user. User provisioning, deprovisioning, authentication, federation, authorization, and auditing. The architecture will enable reusability of identity and access service for all user case in public, private, and hybrid cloud model. It is also a very good practice to employ secure token service along with proper user and enlightenment provisioning with the audit trials. Next one, leverage APIs to automated safeguard. Leverage API is any new security service should be deployed with an API with the help of a REST SOAP architecture to enable automation. Usually APIs can help automated firewall policies and access control at the time of application development. This can be implemented using open source tools such as Puppet in conjunction. So there is so many that are provided by the cloud service provider. Next one, always encrypt or mask sensitive data. Yeah, you must. Today's private cloud applications are a candidate for tomorrow public cloud deployment. Hence, architect application to encrypt all sensitive data irrespective of the future operational model. Do not rely on a IP address for authentication service. IP address is a cloud in nature, so you cannot rely on them for enforcing network access control. Employ certificates, self-trusted CA to SSL between the service deployment and the cloud. Next one is log. Applications should certainly centrally log all security events that will help create an end-to-end transaction view with no repetition characteristics. Cloud are elastic and logs are critical to periodically migrate log files to a different cloud or to the enterprise data center. Finally, continuously monitoring cloud service. Monitoring is an important function given that prevention control may not meet all the enterprise standard. Security monitoring should leverage logs produced by cloud services. APIs and hosted cloud application perform security event correlation. In general, the pattern should highlight some attributes like logical location, protocol, service function, input output, control description, and actor. So that's all about the security architecture design. Now we see data security. What is meant by data security? How we can secure the data? Data security has been functionally rely on service provided by the cloud, and it is occasionally not depend on the platform it rely on some different cloud service provider like AWS, Asus, Google. But there are privacy protection in the cloud. What is meant by privacy protection? Preserve data integrity, data availability, data privacy, and encryption with and a thread. We have data loss, data privacy. Data loss may be by a BYD, external threats or internal threats, and it can be rectified using some security privacy protection. So we have a privacy protection. Your data should be protected from unauthorized access regardless of your cloud decision, which includes data encryption and controlling who sees and can access what. They may be also situation where you want to make data available to certain personnel under certain circumstances. For example, developer need live data for testing apps, but they don't necessarily need to see the data. So you could use a replication solution. Even another example is an Oracle as a data redact tool is a tool. They have a Oracle. It's used for the database. The first step is something you should have already done. Identify the sensitive data types and define them. Discover where the sensitive data resides, classify and define the data type, and create policies based on where the data is and which data type and it can be go into the cloud and which cannot. Too many early adopters of cloud rushed to move all their data only to realize it needed to kept on premises in private cloud. There are automated tools to help discovery, identify organization sensitive data and where it resides. Provided by Amazon Web Service and Microsoft Azure, and even the third party tool include Tabula, Logical and Locker. Next, preserve data integrity. Data integrity can be defined as a protecting data from unauthorized modification or deletion. This is easy in a single database because there is only one way to in or out of the database, which you can control. But in the cloud, especially a multi-cloud environment, it gets tricky because of the large number of data source and the mean to access. Authorization becomes critical in assuring that only authorized entities can interact with the data. This means sticky means of access like a two-factor authentication, logging to see who access what. Another potential means of security is a trusted platform module, TPM, for remote data checks. Next one is data availability. Downtime is a fact of life, and all of you can do is minimize the impact. That's of a considerable importance which cloud storage provide because your data is on someone else server. This is where the service level assessment agreement SLA is vital, and paying a close eye to detailed layer matters. Now just consider, I am telling you an example. Microsoft offer 99.9% availability for major Azure storage option, but AWS offer 99.99% availability for storage objects. This difference is not trivial. Also make sure your SLA allows you to specify where the data is stored. Some provider like AWS allow you to detect in what region data is stored, This can be important for issue of compliance and response time latency. Every cloud storage service has a particular strength. Amazon Glancer is ideal for mass cloud storage for early access data. Microsoft Azure Blob storage is ideal for most unstructured data, while Google Cloud SQL is turned for MySQL database. Likewise, now we see data privacy. A huge raft of privacy laws, national and international, have forced more than a few companies to stay no to the cloud because they cannot make head or tails of the laws or too burden for someone, and it's not harder to see why. All of these protect the internet of the data owner, so it is your best interest to know them and know how will you provide complaints with the companies with them. Next, encryption. Encryption is a data privacy. It's protected and ensured, and the encryption techniques are fairly mature. Encryption is done via key-based algorithm, and the keys are stored by the public provider. Although some business-related apps like Salesforce and Dynamics use tokenization instead of keys, this involves substituting specific token field for autonomous data tokens. Virtually every cloud storage provider encrypt the data while it is in transfer. Most do it through browser interface. Although there are some cloud storage provider like Mega and SpiderWalk that use a dedicated client to perform the encryption. This should all spelled out in the SLA. Many cloud service offers a key management solution that allow you to control access because the encryption keys are in your hands. This may prove to better or at least more risking risk because all it control over who has the keys. Again, this should be spelled out the SLA. If you are in online, you are under threat of attack for threats. This is a fact of life. The old style of attack like a DDoS attacks, SQL injection, cross-site scripting may fade into few years. Cloud service provide us a variety of security tool and policy, but problems still happen, usually originating in human error. Data breach, data loss, hijacking account, cryptojacking. What is meant by data breach? This can happen any number of ways, from the usual means hacked account or lost password laptop to means unique to the cloud. For example, it is possible for a user on one virtual machine to listen for the signal that an encryption key has arrived on another virtual machine on the same host. It is called the side channel timing explorer, and it means victim security credential in the hand of someone else. Data loss. Well, the chance of data loss is a minimal shot of someone logging in or erasing everything it is possible. You can migrate this by ensuring your application and data are distributed across several zones, and your backup your data using off-site storage. Hijacking account. All it takes is one lost notebook for someone to get into your cloud provider. Cryptojacking. It's act of taking over your computer to form cryptocurrency, which is a very compute intensive process. Monitoring for unusual compute activity is the key way to stop this. Application security, the next topic. It is a series of depend policy, process, control and technology governing all information exchange that happens in the collaborative cloud environment like Microsoft Office, Google G Suite, Slack, Box, etc. So if you are employ frequently stored and share data in the cloud application like the one listed above, it is absolutely necessary to add a cloud application safety net to your zero trust security infrastructure. These are the top cloud application security threat: misconfiguring of application setup, unauthorized access, insecure APIs and interface, account hijacking. Before we can evaluate a solution for application security, we need to understand the following challenges: security monitoring, application vulnerability, malware and ransomware, and both application layer DDoS.